In the last video, we went over what GCFs are and then how to factor out both a monomial GCF and a binomial GCF. Now we're going to take those pieces and put it together for one of our first techniques we're going to learn, which is factoring by grouping. Now, factoring by grouping is going to happen in a couple different contexts, but one of the obvious contexts is when you have four terms. So if you have a problem that has four terms in it, let's see, one term, two terms, three terms, four terms. When that happens, you're going to be factoring by grouping. That's the only technique you're going to know. All right, so let's look at it. It says you split the four terms into two sets of two terms, then you factor the GCF out of each pair of terms, and then you look for a common binomial that you can factor out, i.e. using this technique that we just learned up above. All right, it sounds complicated, but it really isn't. Here's what you do. You look at the first couple terms. Now, it doesn't have to be the first couple, but it's going to be pretty common that it is the first couple. And then you look at your back couple terms. And you think, okay, what do each of these have in common? So if I look at the first two terms, they both had an x, so I could factor an x out. So if I do that, what's left? An x plus 5. Now remember, you should be able to distribute and get back what you had. X times x is x squared, x times 5 is 5x. Now in the back two terms, these two, they both have a y in them. So I could take a y, and that would leave me x plus 5. All right, now I can factor out a binomial GCF. There's one term right here, and there's one term right here. Each of those terms has an x plus 5 in it. So you can say x plus 5. That would leave me an x in the first term plus a y in the second term. And there you go. That's factoring by grouping. It's not even hard, right? It's just amazingly quick once you know what you're doing. All right, let's do it again. And so let's practice. So we take the first two terms and kind of think about what you could factor out of them, which would be a b, the letter b. Now you look at the last two terms and you think about what you could factor out of those. There's actually a couple different options for this one. Let me start you off with 3 and let's see what happens. So if I take b out of the first term, that leaves me a squared plus 2. Now if I take the second two terms and I write plus 3, then you'd have a minus a squared. That's how you're going to get the negative there. Minus 2. Well, darn it. See, this is a squared plus 2, and this is minus a squared minus 2. They're very similar, but we need them to be identical. Well, what would help here is if I had taken out a minus 3 instead. If you take out a minus 3, then that'll leave this to be plus a squared, and that'll make this plus 2. Remember, you should be able to distribute and get back. Minus 3 times a squared is minus 3a squared. Minus 3 times positive 2 is minus 6, right? Okay, so then this is a squared, squared plus 2. That leaves you a b in the first term minus a 3 in the second term. Now we're all done. Good. All right, let's move on to C. C is a little bit more complicated, and you're going to see why. So you're thinking to yourself, all right, if I look at those first two terms, actually, I'm going to set this up right now. Okay, so if I look at the first two terms, it looks like they have a 2, right? 2 is the biggest thing that goes into both of those, okay? Then you take the back two terms, and they've got an x, and that's it. There's nothing else. I mean, you could maybe do a minus x if you wanted, you know. All right, so if I do that, that's going to be 2 comes out and leaves you 5x squared minus 6y. Oh, 5x squared, not 4. Sorry, 5. And then if I take a plus x out, that leaves me, let's see, negative 15 plus 8y. Oh, this is awful. This isn't working out at all because I don't have the parentheses being exactly the same. And they're not even close. I mean, the other one that we had, they were close. It's just that it was negative, but this isn't even close. This is a mess. So this didn't work at all. So you might be thinking, oh, that means I get to give up. Oh, contraire. No, you do not. You have to try different combinations. So we're going to try to rearrange. Oops. Hold on. There we go. Rearrange the terms. And we don't necessarily know right off the bat which one's going to go with which. So let's see here. How about we put the 8xy maybe with the 10x? That's one way we could go. Or we could put the 15x maybe with the 10x squared and see where that goes. I mean, we kind of don't know. All we know is that the way it's currently set up is not going to work. So let's take the 8xy. Let's put it with the 10x squared. That way they'll both have a 2x that could come out of them. In fact, I'll put that up right now. So these two would both have a 2x that comes out. Now I can see my term with the y is in the back. So I'm actually going to rearrange these as well. I'm going to put the minus 12y in the back there. So it's going to be minus 15x minus 12y. And these two both have a negative, so I can definitely take a negative 3 out because 3 goes into 15 and 12. All right, let's see if this works. So if I take 2x out of the first one, that leaves me 5x plus 4y. Cool. Now the back ones I'm taking minus 3 out, and that leaves me 5x plus 4y. All right, we did it. Okay. So this worked out perfectly. I rearranged them, and you don't necessarily know right away like the perfect way to rearrange them. You just try stuff, like try fitting it around. Now notice I tried to put the y ones in back because I knew they were going to have to match up. So I put the y ones in back like that. All right, so that leaves me with, let me line this for you. That leaves me with, oops, I guess I'm not going to do that. Hold on. 5x plus 4y. Comes out, because it's in both of them, it leaves you 2x minus 3. And there you go. Oops. I better put that in a box, because that's our final result. All right, last but not least, and that's this one over here. So let's see. This one actually isn't as hard as the last one. If you look at the first two, it's kind of obvious. They both have a 4 and an m that goes into both of those. And then let me just write that out. 4m, that would leave me n plus 7. Intriguing. Look at the back two. It looks like they don't have anything that you could take out, right? And what's more, they're kind of already what we want, right? But there's always something you can take out, and that's 1, right? The number 1, because 1 times n is n, 1 times 7 is 7. So this is plus 1 times n plus 7. Well, that'll be perfect because then I'll be able to take n plus 7 out of both sets. So n plus 7, that'll leave me 4m in the front plus 1 in the back. If it looks like exactly what you want for those back terms, like in this case, it was n plus 7 and that's exactly what I wanted, that means there's a plus 1. If it had been a minus n minus 7, then that would have been a negative 1. Very close to the same thing. All right, we are all done with 6.3 to 6.4 part 1. And then next time we'll come back and do the more tricky problems of factoring trinomials. So I'll see you back here then.